All right, good day, everybody. We are waiting for a few more attendees to come in, so we'll get started here shortly. So we'll just start about 2 after the hour. So appreciate you everybody being here for the DevSecOps webinar brought to you by Red Hat in Crossvale. So we'll get started here shortly. All right, well, welcome everybody to the Crossvale webinar about DevSecOps. Today is December 18th, and those of you attending from YouTube, we welcome you as well. With us today is myself. I am Todd Millard. I am a CEO of Crossvale. We also have JC, who is one of our practice leads around app modernization. Marcos is also with us too. Is one of our architects on the app modernization team. So I'm going to get started and we'll walk through this, the agenda, and talk a little bit about some stuff related to Crossvale, and then we'll hand it over to the technical guys to get in a bit more detail on the engineering side of this. So I also want to thank Red Hat. Red Hat sponsors this webinar for us and this webinar series. If you're interested in seeing similar webinars, please go out to our YouTube channel. You can just go onto YouTube and search for Crossvale, and you can find our YouTube channel that we have plenty of other webinars as well as other videos. Today, the agenda is going to be, well, first we'll do a little welcome, talk about digital transformation, what's going on and the trends there so that we kind of understand why this is important to talk about DevSecOps. We'll walk through some discussions around CI/CD optimization, security and DevOps, modern deployment, managing the complexity, especially at large scale in development environments, and then real world pipeline demo example. And then we'll talk about some actionable strategies, and I'll have an offer for you on the end for those that have attended or watched the YouTube video. The important thing here is we do a lot of videos and we talk about things related to containers because Crossvale is an award-winning global leader in simplifying modern hybrid cloud. And what we really do is we really focus on helping organizations that are either using containers or moving towards containers to be able to get the most value out of them. We've won many awards. And in fact, when it comes to the discussion we're having today about the app modernization side of containers, we were the first global partner with platform automation and application platform specializations for Red Hat. So that's a very high distinction. And this is why Red Hat has invited us in to do this type of webinars, because of the deep expertise that we have. But today we're going to talk a lot about application modernization. And a lot of times we're talking about infrastructure when it comes to containers. And what's important is we need to understand how to educate the application team so that they understand the value of what they can get out of moving to containers and Kubernetes, and then help influence that infrastructure team to know what they want. So hopefully the application guys will be here or see this on YouTube to be able to learn something around how digital transformation can affect them. So we'll get rolling along with the importance of digital transformation. What's happening right now in the world? 92% of executives say digital transformation will become more important in the next 12 months. So they're looking at their environments. And so if you're not seeing this in your organization today, it may be going on behind the scenes where they're looking at improving what's going on in their applications. 78% of companies plan to modernize their custom applications within the next year. There's a lot of stuff going on right now around modernizing app platforms, especially in relation to legacy VM environments. And then how do you move into the modern world, especially with what's going on with Broadcom and VMware? There's a lot of discussions and analysis that's done around that. 78% of companies right now are really looking at actually doing something from the application side. And then 44% of organizations plan to invest in AI ML technologies in the next 12 months. This affects the platform because if you don't know yet, AI ML and you runs on containers. So if you want to keep that data in your control and not push it out to a SaaS location, you want to get container confident. You want to be able to run containers in your own environment. And that's what Crossvale does. We help people do that. We actually have a managed service called PodOps for OpenShift that allows us to be your subject matter expert and help you solve that particular problem. Common application transformation initiatives that we're seeing and what's happening out there in the real world is modernizing existing applications. So obviously, as you're replatforming, moving from legacy VM platforms into new platforms, part of that is trying to figure out, do I rehost? Do I replatform? Do I refactor my monolith? Well, it's a great time to take a look at that as you're replatforming. So this is one thing that OpenShift and understanding the app platform side of this can really do is help you understand how to do that. Developing new cloud native applications. So teams start to move from taking a look at their legacy methods of developing applications and moving towards cloud native applications. And that's something that, you start off with a small environment and you have a great DevSecOps approach to that, which we're going to talk about today. And then it makes it easy for you to get those development teams to be able to move towards the developing new cloud native applications. Adding intelligence into the application. So we talked about AI ML. This is a big initiative now where people are taking a look at their existing apps and going, how do I move these into a spot where they could be more intelligent and they can provide me more data-driven insights into what's going on in my business and provide that business value back that the executives weren't getting before in those applications, and then integrate custom and third-party services. So this is still has been and continues to be, how do we integrate things together? Reasons for choosing containers and Kubernetes. So as people are looking at their legacy environments and trying to understand, when is the right time, if you're looking for more consistency in your environment, this is a massively good reason. 74% of organizations move due to consistency. And we're not talking just consistency of the environment itself. We're talking about consistency of licensing, because right now we're seeing inconsistency happening in legacy environments when it comes to the application platform licensing, giving you that agility to be able to have that business make changes, and they can try things and fail fast in container environments. And it doesn't take as much investment as it does into the legacy VM environments. Portability, this gets rid of vendor lock-in. You can move to containerized environments and now move to run those in many different environments and not be locked into a certain platform. Scalability, auto scaling built into these platforms, having the capability of bursting to the cloud, having ways to design the scalability so that your users can be serviced as their needs change. And then the flexibility. In fact, right now, there's many third-party products that are out there that are developed in a container and also developed, as a VM. So giving you the flexibility to run these in a container where you can save 40 to 60% of the infrastructure cost that you would normally pay because they're more efficient running in containers. So what do you need to transform your applications? Well, you need to have the consistent infrastructure. You need to have that orchestration layer there. That's what OpenShift does. That's what PodOps does, to be able to help you have that orchestration layer so the application team can go in there and build these kind of DevOps, DevSecOps solutions or pipelines out there that can then give you that capability of driving that results in your application. You need the cloud native services. So platform application developer and data services, need to be built into your environment. We can help with that as well. That's going to be something we'll discuss here. Streamlining the security and management. So as you build out DevSecOps, having security management directly just built into your pipeline is a big advantage of modernizing. And then deployment flexibility, whether you go self-managed, you do pod op managed by Crossvale, cloud service consumption. There's many different ways that you can deploy, and having the deployment solved is another great thing about modernizing. Deploying a modern application platform. One of the things that we're going to talk about today, we're going to focus. There's a lot of different things here about container technologies, about Kubernetes orchestration, many different things that could be why deploying a modern application platform is important. But we're going to focus today on the DevSecOps portion of this. And when we look at the Red Hat OpenShift world and why it's so important and what it does for you as an app modernization team, or as an application team, or even when you're looking over on the infrastructure side, one of the things that you really want to take a look at is, regardless of where you want to run your application, whether it's on the edge, in public cloud, you want to run in private cloud, such as Horizon Private Cloud. This is reach out to Crossvale to get more information about this. Virtual or physical, OpenShift gives you the virtualization platform to run your VMs, the container platform to run the containers, has the application platform with all the application services and providing self-service capabilities to the developers, and the AI platform all built in, and gives you that capability of being able to run your modern DevSecOps, because it's going to simplify how you build this, because it has much of this capability built into it. And then we're going to talk about some of the other things that we add to it to be able to bring more capability to you. So at this point, I'm going to hand this over to JC and Marcos, and they're going to move along with this from a more intellectual view around the engineering of this and show the engineering side of this. JC, it's all yours.
Thank you, Todd.
You want me to stop sharing? Do you want to share, or you want me to keep sharing?
I will do.
You'll share? Okay, there you go.
Okay. Well, let's start for the beginning. So most of the companies already have pipelines working, but most of them have dozens of pipelines, and most of them are totally different each other. They have different logic. They don't have security checks. They hard to troubleshoot when they have problems. And what we are trying to do with this is try to have something reusable pipelines that you can reuse for different languages, one per language or several per language, but based on what you are doing. So you can reuse across your teams. You have the security steps within your pipelines, so you can check what you are doing, your code, your image, everything. You are sending the image, and you are doing a faster onboarding for the new developers to your teams. So the step to follow to optimize the pipelines are basically to define the golden pipelines. So you can define what are the logical pipelines that you need to have for the different paths that you have in your company. So you have different languages, such as Java, .NET, and each one, it could be a bit different each other, because the way you are compiling that is totally different. The way you are testing that is different. So you define golden pipelines that you can reuse for those languages. Then you can shift left the build optimization, which means that you publish, test, and do the security checks of the pipelines as early as possible in the development life cycle. So if there is any issue, you are getting that, you are catching that in the early steps and not at the end of the process. This can reduce a lot of work for the developers. So we are thinking on a way that the pipeline starts with when you are pushing a new change on your Git repo. You are building, you are doing the image building, you are scanning that image, you are seeing the image and you are pushing that. And then a second step will do the deployment. The pull-based deployment means that you are doing the CI builds, the design and the updates on the Git, and the CD, the deployment, it will be part of the Argo CD that pull the information from the Git and apply to the cluster that you have. So you have a total control of what is happening there. So every change that you are doing to your configuration is there. If you need to do a rollback, you have the changes that you apply to that cluster. Then you can do the parallelization of the pipeline and partitioning. I mean, as I mentioned before, right now, when you are thinking on doing the pipeline, you are thinking on the work process of the CI/CD. So you are building the application and deploying that to the servers, to the different environments. What we are thinking here is that we are splitting that into two steps. One of them is the build, the CI, and the other one is the CD, the deployment. So once you are generating an image, that image is the one that you have in the dev environment, and you will promote to the other environments. And you don't need to take care about the changes that you need to apply to that image to install in the other environments. So you are delegating that to the CD, the DevOps, that will be in charge of doing the deployment for you. So you just need to focus on the CI, on the build. And then a first step should be the check of that deployment and the quality, observability of what is happening on those applications that you are deploying to your cluster. The idea of this is that you are building one and you are promoting everywhere. You don't need to do an image for each environment. So the image that you have will be promoted to all of them. And you are approving environment per environment. So if you have a new image that is promoted to dev, and you will have several tests that will do a check on that application. If that is okay, you will promote that to the next environment, the QA environment, where you can apply other tests. If those tests are success, you can promote that image to the higher environment, maybe a staging, a beta, a production environment. That is the way that you are doing. One image to all the environments. Only the valid image will go to the latest one. Marcos, will you want to continue with the security?
Yeah, hello everyone. My name is Marcos Rivas. I am a solutions architect at Crossvale. I want to put a little bit also of my point of view on what JC was saying. What we intend to say with golden pipeline is not a magic wand that you use and then it solves all your problem. It's more a golden pathway, which is what do I need to do to ensure that my code is reliable, that is tested, that is secure, and that I can put it with confidence into a production environment without opening for any vulnerability attack or because we are failing the tests and we need to do a rollback. And then, as Jose Carlos was saying before, in an organization we have multiple teams, multiple languages, that require a little bit of different steps. So it's not the same to build a Python application or a Java application. There is a bit of different steps on how you do it, but still what you need to do and what is your golden pipeline, it should be the same. So it's important to keep in mind the reusability and also to keep it open for extension. So if you want to onboard new languages, new teams, then you can do it. And one thing that you can always keep in mind is find a little guinea pig into your organization and use that to onboard these cloud native pipelines and test it in a way that when you have more teams ready, you can start onboarding teams, and then you will have observability out of the box, all the metrics reported out of the box, security reporting out of the box. As Jose Carlos was saying, build once and deploy everywhere very easily. So my recommendation would be just keep that on the back of your head and then just do everything with that kind of mindset. Reusability, extension, use Git as the source of trust, and try to provide it to as many teams as possible. But yeah, let's go ahead. Yes.
Well, moving forward with the security, the old models all about the security, move the security to the end of the process. So you are generating the image, you are promoting the image, but you are testing the security of the image at the end of the process. And sometimes you are ignoring that step, and you are doing that maybe once a week, once a month, or once every half a year. You are delegating that to the last step. Security is the final. It's something that is an item that you have that is in the middle of your way, and you need to accomplish because it's something important for other people's. What we try to do with this is that move that to the initial process. So you are checking everything at the beginning. Moving everything to the beginning means that you can be safe at the end of the process. So you can feel confident with what you are delivering to production because you already have the process of the checks of that image, of that code. And that is why we are integrating the SBOM generation. We are validating that generation of the SBOM. We are checking for vulnerabilities of the code of the image, and we are seeing the image just to ensure that the image that you are seeing at the beginning is the one that you have in production, and no one is replacing that in the middle. So for this, there are several tools. For example, Red Hat already offers tools to check what are the vulnerabilities within the cluster, like the advanced cluster security. And there are other tools that can be to check the image. We have several tools to do that. We have tools to do that at the end within the cluster. We have tools to do that in the pipeline. And we will see that in the demo.
Yeah, and one thing I want to bring to the table is that the good thing about the software bill of materials is that as a developer, when you are building code and then you deliver the code and you scan the final deliverable, and then you didn't pass the security quality, the security vulnerabilities because you have a dependency with a critical vulnerability, then it's a very expensive process in terms of time and resources to go back and fix that until you deliver again. Now the software bill of materials is generated from your own source code. So it's basically a bill of materials that contains every library and package that you are using, and you can check it very early in the process. That's what we are saying by shift left into the development life cycle. Left meaning earlier. So when developers can put a plugin into their IDE, like Visual Studio Code or IntelliJ, that is going to tell them while they are coding well, you have introduced a vulnerability, and you will need to fix it. Now, the pipeline will check that and will stop that to go to any production environment. But still, it gives the developer the information ahead of time so the developer can fix it very early in the process. And then you don't have this expensive operation of when a delivery is final or almost finalized, changing your dependencies and fix your code and anything you need to fix and go through all the process again, because the developer will know it earlier on time.
Another step that we are adding here is to handle multiple clusters, OpenShift clusters, one for dev, one for QA, one for UAT and production. We need to use a central component to do the build, the CI, and another to do to store the image that we are generating, the registry. So we are moving forward to the cluster. We are moving out some process of the process. So there is one single point of the build, one single point to store the image, and multiple clusters to deploy that. And we are splitting that in several ways. So the CI can be in the dev environment. You are building that. You are storing that in your central registry that will be common for all of the clusters that you are having. But the CD will remain in any cluster that you have. So the CD will be in charge of deploying everything that he wants in my cluster. I need to deploy this application. I will take care of this application using the common registry that we have. And finally, when we are deploying something, we need to have observability to what we are doing. Most of the time, developers do his work, add some logs, and that's it. And that's the end. So when we go to debug any problem in production, there is no observability. We don't have metrics about application. We don't have metrics about the flow that is moving through the different application, the requests that we are doing from one to another. And that is what we need to add observability to this. So we know what is the number of pods that we are running. We know what is the memory. That's something that is by default in OpenShift cluster, but we don't know how the application is working. What are the metrics that we need to know about my functionality that I already have in my application? And we need to add that. And we also need to add traceability of the information that we are sending from one to another. And for that, we had several tools for doing that. For example, Red Hat already implemented the OpenTelemetry on their cluster. So it's quite easy to install this and see what is the traceability between the different applications that you already have. So if you have communication between two applications, you will see what is the information that is moving from one to another. Not the information, but the request that you are having from one to another. And you can see what is the timing that is taking when you are doing a request from the application A to the application B and the B to the C. And if you're having some bottlenecks, you will see that better.
Yeah, and not only that, JC, so OpenTelemetry right now is the second largest growing project on the Cloud Native Computing Foundation, only after Kubernetes. So that gives us an idea of how important telemetry is, how important to know how your architecture is behaving and what is happening with your messages. Because while you are going towards a more distributed architecture, it could be a little bit difficult to know what is going on. And the Red Hat OpenTelemetry is in my opinion, is a very good solution. Is relatively easy to implement, relatively easy to integrate into your OpenShift deployments, and it gives you that observability that it may be the thing you need if you don't know what is happening in production, or as JC was saying, if you have a bottleneck, it could help you identify very easily where the bottleneck is.
Let's see the security into the DevOps and how to integrate the security into our workflows or pipelines. As we commented and we said, one of the things that we need to do is move the security to the left, shift the security left. So we need to ensure that we are doing the security checks before generating the image, before promoting the image, before deploying that image. So we need to do the quality check of the code. We need to check the code, the security. We need to apply checks, scan the code just to ensure that we are not creating vulnerabilities and we don't have vulnerabilities on the libraries that we are using. We need to scan the dependency that we are using during the build. And then we are generating the SBOM file that will help us to identify future problems, future vulnerabilities.
Yeah, and a couple of things to know about that is how do you balance your development speed while keeping the security as secure as you want. And it's related to what I was saying before. If you try to identify security vulnerabilities earlier into the development process, then you can fix them. So by integrating these tools, by integrating the tools into the developer environments, and by using them into the DevOps pipelines, what you can do is try to identify this problem earlier on the process. And also, one of the good things about the Red Hat tools is that it allows you to monitor your response. So do you allow me to share for a second, JC? I want to show one thing to the audience.
Yep.
Okay, let me share. Give me one moment. Okay. Can you see my screen?
Yep.
So this is the Red Hat Trusted Profile Analyzer. So this is a little bit related of what I was saying. So the software bill of materials can be generated into your pipeline, and then it can be uploaded into this tool. And this tool, one of the things that it gives you is a bit of information about the software bill of materials that you have updated. Then you can watch some of them, or maybe if you want, all the software bill of materials that you have updated. And then I have uploaded one and generated a vulnerability report for one of ours. And then it gives you, well, your current source code has these two medium vulnerabilities and is affected and is a medium. And then you can see what packages are affected, or go to the vulnerability itself. Well, download the vulnerability report, or go to the web page is not working. I guess this is demo effect. Give me 1 sec. So you can see the vulnerabilities and what SBOMs are affected by them. And the SBOM is static. So when you generate it, it will list your packages and report them. And the Trusted Profile Analyzer can cross-reference your software bill of materials with vulnerability databases. And if there is a new vulnerability into one of your dependencies, it will show it here. If there is a vulnerability that happened after you upload the bomb in one of your dependencies, it will say, hey, there is a new vulnerability with this identifier, and it's a high, critical, or a medium, or whatever is the classification of it. And then you have the information about all your software and the vulnerabilities that are affected by them, and then you can decide what are the steps you want to take in order to mitigate them. One of the important things is that this does not only fix your vulnerabilities that you have introduced into your software development process. It also helps you by identifying vulnerabilities in any of the dependencies that you have, or of the dependencies of the dependencies. Because by using some products like Red Hat products that are based on open source components but certified by Red Hat, so they are secure, they are validated, are still based on the open source world, and sometimes new vulnerabilities can appear, or someone could try to introduce or try to execute any kind of attack through these vulnerabilities, and then this gives you up-to-date information about your software, what are your vulnerabilities, and why you should do it, or not what you should do, but it gives you information of how critical the vulnerabilities that you have are going to be. And can you share back the PowerPoint again, JC, please? Also, one important thing that taken into account into security is trying to, in addition to the bill of materials and also scanning images for vulnerabilities, it's always recommendable to sign your images. This is when you generate a container image, you can sign it, and then when you are going to deploy it, you can verify the signature of it. So you can verify that that deliverable was generated by one of the keys that is actually your keys, and that is signed by one of your keys, and that the key is still valid. And this prevents that if someone wants to, or someone tampered with your software delivery and tries to inject a malicious artifact, then it will hopefully don't get a hold of your signature keys. And then you will have more confidence that what you are running into your environments is secure, because you yourself or your organization has signed these artifacts. Another important thing, from my point of view, is to always try to, as I said, integrate the security, try to scan or try to identify the vulnerabilities as soon as possible, but still have the ability to validate the software's supply chain and to be able to establish a security quality gate into your delivery pipelines that has to be met. In that way, what you have is trust that the artifacts that you're running are secure. And by integrating that into your DevOps pipelines, what you can do is be sure that every artifact that you are deploying into a production environment is as secure as it can be, and it follows your security principles and your security policies that you have defined within your organization.
In regards to the security, a final step should be to add observability to your reports that you are generating. Everything that you are generating here is spawns, for example, are files that you can handle, that you can check and you can review. There are tools that, like the ACS, that can check the current status of the world cluster, just to ensure that you have or not vulnerabilities with any of the images that you are running, any of the tools that you are running there. And we also need to enforce that, to use this kind of tool. So this not only I'm generating the image, I'm sure that is true, is safe, because I'm following all the steps within my pipeline, but I also need to follow the security checks in the future. I also need to continue checking that using other tools that like the ACS to check the compliance reports and ensure that everything is in place and there is no new vulnerability that is affecting to any of the previous images that was fine to this rule. And also, we need to consider that the configuration is also part of the security. Every time that we are doing changes on the configuration files, on the manifest that we are using to deploy something, we have risk of having a problem in production. So we need to reduce that number of changes that we are applying to that. And for doing that, DevOps help us to remove that kind of problem. It's not only for deployment, it's just a mechanism that can help you to ensure that everything that you have is in the right way of the deployment, and you don't need to change that. And we need to find a way to reduce the number of changes that we are applying to that configuration. So for doing that, we can suggest to do automatic updates on the configuration, maybe use tagged images that we will see in the demo, and that kind of things that will ensure that the configuration is safe too, and you are not changing that. Let's move forward. So right now, the modern practice is that the way we are doing the deployments to the different environments used to be manually, risky. We need to do that nightly during the weekends, and it's hard to roll back. And the way we want to change this is trying to have settled on time. We can have a process and we can repeat as much as we want. It's automated, and there is an instant rollback. If something happens, we can roll back to the previous step without downtime. And this is what we pretend to have using different deployments ways, like the rolling of days, blue-green deployments, canary deployments. But the hard part of this, and we have experience with that in some clients, is how we do the deployment to the changes to the schema of the database. And there are tools for doing that, and we need to consider that in our pipelines. So if we need to do changes on the database, we also need to take care of that. We need to plan that. We need to plan the changes that we need to apply and the rollback of those changes, just to ensure that the way that we are applying is able to be rolled back. You are able to do the rollback of that. Managing complexity. Well, this is part of what we have been talking during the world time, and I think we can just summarize. One of the things that we can do to manage the complexity is doing the golden path and golden pipeline. So you can identify what are your different paths: Java, Quarkus, Node, Python, .NET, and the golden pipeline that you want to apply for those paths. I want to do the build, I want to do the test, then I want to scan, sign the image, deploy. That is one of the steps that we need to ensure. DevOps at the source of truth is, I think, in my opinion, one of the most important parts of this. You are splitting the process of the CI/CD. Build will be happen once, and CD will be in charge of the DevOps. Tools like Argo CD will take care of your cluster and will deploy that for you. And you don't need to apply any change on the configuration or the minimum changes on the configuration. You just need to focus on the build of the image, on ensure that the image that you are building is secure and safe to deploy in the environment. Observability is something important that we need to add. So when we have something, we need to ensure that we can check what is happening there on that application, on that communication between application, on the result of the reports that we have. If there is any vulnerability, what are the compliance reports that we have? If we have resolved of that compliance report. And I think we can move to the demo and explain that, I think, a bit faster because we have not so much time. What we did for this demo is something quite simple. We have been working on a pipeline that is doing more or less what we mentioned before. There are a few applications. In fact, there are 3 applications: one UI, 2 backends, bridge services, that are doing just a request to a system or request to a system on the cloud. The UI will request to those services, and those services will redirect the request to the system of record. We have one application, one backend application that is a Quarkus application, and another one that is a .NET API application. And we have, in this case, 3 environments, but we are going to focus in only 2, dev and QA. And every time that we are doing a push to the dev environment, the CI pipeline will start. The CD will happen thanks to Argo CD. So if we think on the 2 main applications that we are going to focus, the backend application, the .NET application is built, the CI.NET application, we did that using Tecton, using the pipelines that OpenShift already offered to the users. On the Quarkus one, we decide to use a third party because most of the companies used to work with another CI pipeline, Azure DevOps, sometimes using GitHub, GitLab, other tools. So we just want to ensure that we are showing that you can do this with any other CI tool for doing the deployment. And the CD, we are delegating the CD, the DevOps, to the Argo CD. We are storing the image to the GitHub registry as external registry. So all the environments will have access to this registry to download the signet image that we are generating. Okay, so every time that we are pushing something to any of the Git repo that we have for those applications, the CI pipeline will start, will build the application, will store in the registry, and the Argo CD will update that in our cluster. Depending of the version of the application that we are using, of the branch of the Git that we are using, it will deploy to the dev or to the release environment. So let's focus more or less on a bit explanation of how is the pipeline working. What we are doing every time that we are doing a merge to the develop branch, we are doing the lightning, which means that we are checking the code. We are doing the quality check of the code. Then we are scanning the code just to ensure that we don't have vulnerability on the code and the libraries that we are using. Finally, we are doing the build of the application and executing the unit test. If everything is okay, we can think of start building the application, the image of the application. Once we have the application already in place, we are scanning that. We are generating the SBOM file of that image. We are sending the image and we are uploading that to the registry. When we have that image already in place, so everything is fine right now. So the image is already stored in the registry. The smoke test will run on the dev environment. So there is a test that we are running. We are starting an ephemeral environment where we are starting that new image and we are executing some tests to that application just to ensure that the application is working as expected. That is part of the functional test. that we want to do. If everything is okay, we will tag the image as valid for the dev environment. If that image if the test is invalid, there are errors on the test that we are running, we are not tagging the image, which means we are not deploying the image to the environment. Same happens to the release environment, with the release to the QA environment. So we are doing the work process and we are doing the smoke test in the ephemeral environment. If the ephemeral environment, if the tests on the ephemeral environment are okay, we are tagging the image as QA, and we are deploying to the QA environment. And then we are running the rest of the tests that we want to do for the QA environment, regression tests and all the tests that we want to run there. If everything is in place, everything is okay, we can tag the image as valid for prod, and we can deploy to prod. But that's another part of the product. We are just focused on the develop and the QA. Okay. So here is an example of the application, the Argo CD application that we have. Well, in fact, the application is quite simple. It's just doing a request to the Rick and Morty API that is public on the internet, and there is another API that gives you some advice. So the Quarkus application will get information about the Rick and Morty API, and the .NET will get information from the advice API. So this UI, every time that you are clicking here, is doing a request to the API, is showing a new character. So if we want to do a change on the application, we just need to go to the code. Let's start with the Tecton one. That is this one. And we are doing this, for example, change. And we are uploading this to the develop branch. The commit is ready. So if we go to the cluster, we will see that we have a pipeline here that is running in the CI. That is this one. And this all the processes that is doing the pipeline. It's cloning the repository, it's checking the format, it's doing the build, it's pushing the image, and it's doing the scan and the spawn. This one is a bit simple, the other simplex, the other one is a more complex. In the meanwhile, because the one that's running in GitHub action is taking too much time, I will do the update on the other one. That is this one. Let me close everything. So let's go to the, for example, let's reply with something, but not something here. Let's do the change here.
So JC, if you're a current customer using OpenShift or looking at moving towards OpenShift, this is a prescriptive approach that we have that we could come in and help their team reproduce this in their environment without them trying to reinvent the wheel and figure all this out on their own. Is that correct?
Yes. Most of the companies, what they have is their own CI platform. DevOps, Azure DevOps, for example, is one of the most common. There are others that want to use other tools like Jenkins, very old one. I want to use that. Other want to use, for example, GitHub Action. That is the CI part. But the CD part used to be the same for all of them. And that is the Argo CD. So when you are doing the build, we can focus on the CD. That is the new part that is going to be for those ones that want to adopt OpenShift. how to deploy the new application that I'm generating. So for example, on this one, we are doing an update in the release branch. I want to do the change on the release branch. And we are starting that. This is going to trigger the CI pipeline that will do all the steps that is going to happen. And the steps are bigger than that. So as this is going to take some time, I will get some examples that we already have in place. So we can set here an example of the previous one that we did when we are doing the build. We are doing the lightning of the code. We are checking scanning the source code. We are building the application, building the container, the image, creating the spawn, scanning the image, and sending the image. And the result of this is going to be the spawn file that we can download. For example, here. And this file can be uploaded to the Red Hat Trust Profile Analyzer. So if we go here, we can generate the vulnerability report of the file that we are using, for example, this one, and it's going to analyze and provide us with all the details. There is an operator in OpenShift that can do this for you. You don't need to load that. You just need to use the operator for doing that. As we are doing two different applications, we are tagging those applications. So we have the dev tag that will go to the dev environment and the QA tag that will go to the QA environment. So if we focus here, we notice that this application is already in place. We have the application in the repository. And if we go to the Argo CD, we will notice that the new application that is the for details. So we have the application that we are using the tag dev and the application was already built a few seconds ago, the new version, but the tag of the image is exactly the same. It's using the same tag, but if we check the registry for this application, we will notice that the version of this image is of 5 minutes ago when we generated it. And same for this one. This one is already in place. We are generating that. It's doing all the steps. Oh, something wrong here. It's failing. There are tests that are failing, which means that we cannot deploy this application to the environment. If we fix
good
that,
thing. So the tests are failing, meaning the pipeline's doing what it's supposed to do. It's say, hey, you can't be deploying this. So you got to go on there and fix this. This gets pushed back to the developer to get fixed.
Yep. If we do that, this is the release.
So for those that have long release cycles right now, like what we're doing here is being able to then, I noticed you developed this in Quarkus, which, you know, for those of you that are using Java, Quarkus is a lightweight version that could run, designed to run in containers. Another way to get a whole lot more efficiency. We can actually have another entire webinar just on that. But like moving to much release cycles that don't take as long. You know, if you're doing like 60, 90-day release cycles now with this, as we move to microservices, CI/CD pipeline running in OpenShift, you can cut these down to release much sooner, so you can get the business value faster. And all of this is, you know, dependent upon, you know, you got to become an OpenShift customer. Come into OpenShift. Let us help you in OpenShift, and let us help you with your DevOps pipeline here. Now we are about, how much more do you have on the demo? Because we're about a minute over right now, JC.
I think it's just tell about the OpenTelemetry that we already have in place. Every time that we are doing a request from one service to another, we are adding this tracing to that communication. So we already installed the OpenTelemetry operator within OpenShift. We configured that. It's quite simple to install that within the application, just a few steps to configure something. You can configure that quite simple for several languages. Just need to add a manifest just to configure the language that you are of the application that you are running, and it will that do for you, so you don't need to take care of that. So for example, for the .NET, we created the instrumentation artifact, and it's adding all the information that the application needs to add the OpenTelemetry information. So when you are doing a request to that application, you can have the tracing information here. So you can see that we are doing a request to the health check of the advice API, and this API is this. This is the timing that we are getting also. It's something quite simple. We are adding more information to the developers when they need to debug some problems in production or in non-production environments, and that helps you a lot when you need to do that debug.
Very good. Awesome. Here, let me thank you so much. Lots of great information here on DevSecOps. Let me just share my screen here as we close this out. It is coming up here. All right. Zoom and go out to this slide here. All right. So for those of you that, if this was interesting and you would like to take a look at this from your organization and how we could help you with your DevSecOps, we actually have a DevSecOps proof of value. This is a 2-week proof of value that we do. We actually have funding from vendors to help with this. So if you're interested in us coming in and doing a DevOps review, taking a look at your OpenShift environment, and either if you're new to OpenShift, help you take a look at OpenShift from how we would deploy that in your environment, and then how we would design this prescriptive approach and show you an example of your workloads running through this. Reach out. All you have to do is go to crossvale.com, contact us. So you can go out onto our website. You can find the sheet to contact us, and just say you're interested in the DevSecOps POV. Someone will reach out, set up a discovery session with you, so that we can work through this. We need to build out the custom scope and then submit that to our vendors to help get the funding. So reach out. Appreciate your time today. Thank you, JC. Thank you, Marcos, for all of your insight on this. If you guys have any additional questions, for those of you that have watched this either on YouTube or watched this webinar, go out to our crossvale.com, contact us form, ask the question. We'll get an engineer or person on the sales side to reach out to you to be able to get answers back to you. Thank you guys so much. Have a wonderful holiday.
Thank you.
Thank you, everyone.